Welcome to Milkwood's Resilience Starts with Healthy Soil mini workshop. I'm Nick Ritter. First up, I'm just going to go through what we're going to cover today so you all know what's going on. First, we're going to have a quick chat with Matthew Evans, the gourmet farmer, on his new book, Soil. Then we're going to talk a little bit about why we want healthy soil and give you a few different lenses through which you can understand soil. The first one's going to be all about soil structure. The second is soil chemistry, and then we'll do soil biology. And for each of those, we're going to go through how you understand them, how you observe your soil through those lenses, and then how you fix things, how you correct things and make your soil healthier and happier. Finally, I'm going to go through Milkwood's 7 tips for healthy and resilient garden soil. After that, I've got a special little something for you all. And then we're going to get into your questions and try to answer all your questions about how to make healthy soil. So before we get into that though, I just want to frame for those people who don't know us that well, what is Milkwood? Well, we're an independent, for-purpose education provider that's been running courses for nearly 15 years. And in that time, we've helped more than 15,000 people learn all kinds of things, from permaculture design to mushroom cultivation to regenerative agriculture techniques for the broadacre, market gardening. We've done natural beekeeping courses, backyard vegetable garden courses, fermentation and natural cheese making courses, and so many others. And a big thread throughout all those has been healthy soil. So we've been teaching this stuff for quite a long time to quite a lot of people. We started off in our wool shed, way up on the family farm up outside of Mudgee in New South Wales. But we've been lucky enough during that time to run courses with farming legends like Joel Salatin, the fermentation master Sandor Katz, and our permaculture heroes like Rosemary Morrow, and of course the co-originators of the permaculture concept, Bill Mollison and David Holmgren. In fact, we were lucky enough to live on Meliadora, David and his partner Sue's iconic permaculture homestead in central Victoria. A few years ago, we got the opportunity to move to Lutruwita and take our courses online. And we're really proud of our permaculture living course with Kirsten and myself and David Holmgren. We only run the course 4 times a year, and the last one for 2021 is open for enrolments right now. There's more information about that on the website and in the email you'll get after the workshop. So if you're interested in that, check that out. But that's enough about us. Let's get into the workshop. Right, why do you want healthy soils? Let us know in the chat so we can make sure that we really get tailor this workshop a bit to your needs and get your questions answered. For me, the immediate thing that comes to mind is that I want healthy, homegrown food. That's the thing that I first think of when I think of healthy soils. But I really want that for our son, Asher. But I actually want much more than that for him. I want him to live on a healthy planet with clean water and strong communities. And healthy soil gives us those things, whether it's on our farms or in our backyards. And I don't want him to suffer the effects of catastrophic climate change and the political instability of global food shortages. And healthy soil helps protect us from those things too. Our mate, Matthew Evans, has just written a book about that and so much more. It's called Soil, The Incredible Story of What Keeps the Earth and Us Healthy. Some of you might know Matthew from his TV series, The Gourmet Farmer. Matthew and his partner Sadie are good friends of ours, and their place, Fat Pig Farm, is only just down the road from here. So first up, we have a little treat for you. A little earlier, we recorded an interview with Matthew all about soil, and we thought it would be a good way to start this workshop. So here it is. Hi, Matthew. Thanks for coming along today.
Pleasure, Nick. Anytime anyone wants to talk about soil, I'm there.
You've written this amazing book. It's beautifully written.
Thank you.
I've been finding it quite engaging. Thank you very much for doing that.
Look, I think this is the book I wanted to read about soil. I got excited about soil really late in life and didn't realise how incredible it was.
for those of us who haven't really thought much about soil in the past, what actually is soil? What makes soil
Soil.
healthy? Yeah, what makes it soil?
Yeah, so soil, I guess, it's dirt with some other stuff, and so dirt is essentially just crushed up rock, pretty much.
Yeah.
So the bulk of soil is the weight of soil is forms of crushed up rock. So it's rock that's been broken down physically or chemically, generally, and so it's sand, silt, and clay usually, and that's just grades of how fine it's been crushed. And then it has some dead stuff in it, so organic matter. So it could be dead roots or dead leaves, but it also has living things, and that's where it's a tiny fraction of soil, only about 1% at the most, is living, and that's it can be obvious things like worms or soil mites. You can see it might be fungi. You might be able to see the white threads of fungi through the soil, but it's also microscopic things. And that's where my mind got blown when I started to think about soil, and someone said, there's more living things in a teaspoon of soil than there are humans on the planet. So 10 billion living things in a teaspoon of healthy soil. And when you hear that, you kind of go, that's what makes soil soil. That's why it's not just dirt. So it's not just crushed up rock. It has a food source for the living things, and it has these living things. And the living things are living in symbiosis with each other, but also living in symbiosis with plants. So for me, one of the definitions of soil is, yes, it has crushed up rock and it has some dead stuff and it has some living things, but it also has an association with a plant, or has recently had an association with a plant, because all the things living in soil need a food source, and the plant is the food source.
Yeah, that magical photosynthesis, this incredible ability of a plant to turn air into peaches. And then the sugar that it then pumps into the soil to feed that.
Yeah, that idea. And I thought it was like you. When I was at school, photosynthesis was, plants breathe in, we breathe out carbon dioxide, plants breathe in carbon dioxide, breathe out oxygen, the oxygen we breathe in. So they help us breathe. And that's not actually the most magic. The magic thing is creating sugars, using the sun's energy to create sugars out of carbon dioxide and water. And so those sugars they use to make the peach and to make the peach tree, but a lot of those sugars, 20% at least, the plant feeds to the things under the soil.
Yeah, and that was a remarkable fact when I learnt that, this idea that, these plants out there that are growing, trying to build their own bodies, are actually, constantly pumping sugar and fuel down into the soil to feed the soil microbiome.
Soil science is really quite amazing, but you need to, when you're thinking about soil, you kind of got to also think about plants. And this is where I think sometimes the connections are lost, because someone's researching soil and someone's researching plants, but they're actually interacting. And plants, we now know, can be dribbling out up to 100,000 different biochemicals into the soil. So through the ends of their roots, they are dribbling out not just sugars, but it could be amino acids, the building blocks of protein, but it can be up to 100,000 different chemical substances that are put into the soil. And that allows plants to communicate with each other, to communicate with microbes. I mean, it seems fantastical and weird and sort of sci-fi, but that's the system that has been built over hundreds of millions of years, where a plant needs soil and it needs things in soil, and it can only get them through an association with living things in soil.
Yeah, it's that thing that we like to do, isn't it, where we try to pull apart nature into its constituent elements. And I can't remember the exact quote, but something about you cannot unpick a thread of nature and expect the whole carpet not to unravel. Everything is so deeply connected, and it's especially true in the complexity of the soil.
Yeah, and I think what's really interesting is as we're making these leaps and bounds in terms of understanding what lives in soil, what we now know is that we don't know what 98% of them are. So we know they're there because we can do shotgun DNA analysis and all sorts of stuff like that, but we don't actually know what they are.
Or what they do, or how they react.
Yeah, we don't need to actually identify all of the thousands or tens of thousands or hundreds of thousands of species of bacteria and archaea and fungi and protists and stuff. But we need to understand that they have a purpose and a role, and they exist for a reason, and we don't need to name them all, and science will try to, but we need to understand that it is a complex living ecosystem underneath our feet, that it's not just crushed up rock, it's not inert, that it actually has biology.
What would you say for perhaps people who haven't got access to a garden or aren't farmers? What's the way that the one way that they can do the most to support this incredible world that's down there?
I think the most important thing is diversity. So if you have access to soil, growing a diversity of things, but if you don't, farmers and growers produce things on your behalf, and every plant takes something from soil and every plant gives something from soil, and soil likes to have a diversity of plants growing in it. So if everybody just buys carrots, broccoli and potatoes, which is pretty much, if you're a market gardener, that's all you grow, that's how you make your money, that isn't good for soil. What soil wants is 60 or 80 different species. So it wants some kohlrabi, it wants some spigarello, it wants things that you probably haven't heard of, or celeriac. The more you can eat a diverse range of things that are grown in soil, the more that allows a farmer to be able to replenish their soil and nourish their soil, because then they can grow the diversity that soil needs. So as an eater, you can directly affect soil health by eating a diversity. But the beautiful synergy is that when you eat a diversity of plant products, you end up with a more robust immune system. And we know this. If the wider variety of plant products you can eat every week, the more you nourish your own immune system by feeding your gut microbiota, the things that live in and on us. And at the same time, you're feeding soil.
Yeah, I was actually struck by some of the simple stuff in the book. Like things that you can do to make sure that your soil is healthy. Make sure you water it. Really basic stuff like that. Keep it moist.
Yeah.
Because guess what? Water is life.
And it is that's the great thing about, if you've got a patch of land and you want, it could be, just a tiny little area of your courtyard or something, you want to grow something and you don't have time and you want it to be your verdant garden, well, make it verdant with something. Just water it so that something grows, because those things are feeding the soil and they're actually doing the soil good in the time that, before you create the garden. So you might think of them as weeds, but they're not weeds. They're fulfilling a role in the ecosystem, probably a very, very important role. They might be taking nitrogen out of the air and storing it in the soil or whatever they're doing. And they're kind of fixing the soil ready for when you want to manage it. And as humans, we can't run the system, but we can manage the system. And I like to think of us as conductors of the orchestra. So we can sort of put in place what we're trying to get out of the soil, but the people playing the trombone and the people playing the castanet, well, that's the microbes in the soil. So as conductors, we are just putting in place and directing what happens, but the work is being done by the trillions of things that live in the soil.
So is there any other tips or things that you'd like to say to home gardeners about the best way to encourage their soil to be healthy and to bring health into their life through caring for their soil?
Yeah, look, I guess, and the stuff that, having spent like a couple of years researching and reading really dense scientific reports and sort of analysing it, it comes down to really simple stuff. Like, what are the three most important things for your garden? In this order: compost, compost, and compost. I mean, it's like it's what we knew 200 years ago.
Yeah.
It's not. That's what's beautiful about it. It's not super complicated,
no.
Despite the complexity in the system. So it really boils down to fairly simple stuff. Feed your soil. If you can, get some kind of seaweed or find your own seaweed and brew it up and feed that. Putting on compost. Keeping green living things, mulching bare earth where you can. Try not to turn it over too much. They're the sort of the simple things, and that, especially in a domestic sense, is really not that hard. It gets harder to manage, as you get bigger, but it's still not impossible. People are doing brilliant things on scale, and I think that's the beauty of having your own patch of soil and being able to manage it and being able to grow something, is that you can do stuff that nobody can do in a commercial sense. And everything you grow, and this is the really magic thing, the more you nourish your soil, the better everything you grow tastes. And I think that's the book was driven partly by going, why does every year the carrots, why do they taste better and better? And it's the same species, we've got the same sand, silt and clay, the same crushed up rock that we had 10 years ago. We've got the same rainfall, we've got the same amount of sunlight. What's changed? The biology, the living matter in our soil. And I think that, and then seeing that on the plate, the flavour change on the plate, like what joy.
Yeah, especially for a chef.
Yeah, especially for a chef, a glutton, which is my original.
Fantastic, Matthew. So the book is Soil, the incredible story of what keeps the earth and us healthy. I might just get you to finish by reading this last little paragraph of the introduction, which I think is just beautiful.
I'll need my glasses for that. No worries. We have the capacity to slow climate change, grow an abundance of better tasting, nutrient-dense food, gradually alter the very genetic makeup of our bodies for the better, and help heal the world. The answer is right in front of us and all around us and underneath us. All we need to do is stop treating soil like dirt.
Brilliant.
No,
Thank you, Matthew.
Thank you so much, Nick.
If you want to grab a copy of Matthew's book, go to their website and grab one for yourself or for a friend. The website is fatpig.farm/shop. You can get a personally signed copy from Matthew, which would be a treat. Now, let's get to understanding your soil. So, there are 3 different perspectives that we can use to examine our soil. You could think of them kind of like lenses that you can look through to examine your soil. The first lens is the structural lens, how soil behaves physically and how it holds together and how it holds on to other things. The second lens is chemistry, what elements and compounds are in the soil and how do they interact and how easy they are to access. The third lens is biology, and that might be the most important one. What's actually living down there in your soil and how can you make it thrive and multiply? It's only when you ensure that each of these aspects of your soil is in balance that you can truly have thriving, healthy soil. So, we're going to start with soil structure. The structure of the soil determines how the soil physically behaves. This will also influence the soil chemistry and how easy it is for the soil biology to multiply and thrive. Now, we all want deep chocolate cake soil like this. But it's very rare that your soil is going to start off this way. Often it's going to be much harder or way less friable. So how do you actually get there? In a structural sense, there are 4 main ingredients that determine how soil behaves. Like Matthew talked about, the biggest part are the mineral solids of sand, silt and clay, and they make up nearly half the volume. And only a small part of healthy soil is actually organic matter. This includes all the living things. It's less than 10% of the volume. The rest isn't solid at all. It's water and air. And together, they take up about half the volume too. The actual amount of water and air varies quite a lot as you water your garden or as it rains and as it dries back out again. That's why it's incredibly important to avoid compaction. You don't want to squish all those void spaces and exclude that air and water. How your soil actually behaves structurally is really down to the ratio of those mineral solids, the sand, silt and clay in the mineral solids part. So that's due pretty much to the massive size difference between these ground up bits of rock. You might think of a grain of sand as being really small, but they're giant boulders compared to the other 2 types of particles. These little guys are silt particles, and they are about 1/40th the size of a grain of sand. And those little tiny dots there, they're clay particles, and they're about 40 times smaller than the silt. That big sand particle is 1,600 times larger than the clay particles. Clay is so small, it starts to behave completely differently. It sticks together and forms big gloopy chunks and kind of bonds to other elements and nutrients in the soil. Why is this structure so important? Well, soils dominated by clay behave very different to soils dominated by sand. Clay soils, well, they have some really positive features. They hold on to nutrients really, really well. And they hold on to water well too. On the downside, they can become heavy and waterlogged, and they can be really hard for plants' roots to penetrate. And of course, they can be really hard for you to dig. Sandy soils, on the other hand, well, the good thing about them is they're really easy to dig and they're not easily waterlogged. But on the downside, they really can't hold on to nutrients very well, and they can't hold water very well either. There's a saying that clay soils will break your back, but sandy soils will break your heart. So, what are you going to do to figure out whether your soil is a clay-dominated soil or a sandy-dominated soil? Because you're going to have to use different approaches to fix each of those different types. Well, you start by just taking a closer look at your soil. You can often actually see the particles. The other thing you can do, you can feel it between your hands. In permaculture, we always say observe and interact. And getting actually hold of some of it and getting a sense of it, having a smell of it, is a powerful way to understand your soil. And how does it behave? If it's really hard to put a spade into, then you can probably imagine that it's pretty high in clay. Finally, if you want to be really accurate and work out what your exact soil texture is, then we recommend that you do the jar test to determine what your soil texture is. So it's really not very hard at all. You get yourself a nice big jar, a mason jar or a preserving jar like this, and you fill it about half full of your soil. Now, it's not a bad idea if you pull out any rocks or any big chunks of organic matter. But just about half full, nice big jar, and then add just a drop or so of dishwashing liquid, just one drop like that, just washing up liquid, and then fill your jar 90% up with water, almost to the top. Put your lid on tight, make sure it's tight, and then we want to shake it. Give it a really, really good shake. That dishwashing detergent just helps all the dirt get saturated by the water. You want to shake that for at least 3 minutes. And then you can't see anything. You've got to let it stand overnight for those particles to settle out. So I've got one that I've done previously, just over here. And what you should be able to see in that is that all the different particles have started to settle out. Oh, camera comes into focus. And we've got the water, the organic matter floats on the top, and then we've got the sand at the bottom and the silt in the middle and the clay up there. So I've got a diagram to make that a little easier to see. So the first thing is the jar's full of water, and the organic matter will float all the way to the top. Then the first thing to settle out, because it's the largest, heaviest particles, is the sand. Then the silt settles out, in the first sort of 10 minutes or so. And finally, the clay takes ages to settle. It might take a day or so for it to all settle on the surface and you get back to reasonably clear water. So what you need to do then, once it's all settled like that, is you need to get yourself a ruler, like this one, and measure the different heights of those different materials. So in this case, I made it a little simple for our example. You can see there that there's about 100 millimetres, 10 centimetres or 100 millimetres of total solids from here, the bottom of the jar to the top of the clay. And if we measure the sand, we've got about 50 millimetres of sand. And you might be able to see there that clay, we've got about 15 millimetres of clay. So that makes it really easy. 50% sand and 15% clay. So the rest is silt, so you don't even need to measure that. That's 50 plus 15 is 65, and that leaves, Yep, 65, which leaves 35 millimetres of silt. So that makes it 50% sand, 15% clay, and the rest, about 35%, is silt. It's those ratios that determine your soil texture. When you hear gardeners talking about a clay soil or a sandy loam, that's what they're talking about. Now, this beautiful thing is the soil pyramid, an amazing little triangle plot chart that was developed nearly 100 years ago, way back in 1927 by two scientists called Davis and Bennett. All you need to do to work out your soil texture is to use two of those three percentages. So in our example, we've got 50% sand. You know, here's the sand axis, and it goes up at this angle. So 50% sand, and we had 15% clay. So this is the clay axis, and it's horizontal. So you just go across here, and where they cross, that's what type of soil texture you've got. In this case, in our example, we've got a loamy soil, a lovely, loamy, equal sort of soil. It's not too heavy in clay. It's not too sandy. It's not too silty. It's right in the middle. We don't even need to calculate the 35% because it can't be anything else. So, bingo, we have a loam soil. Lucky us. If your numbers aren't as neat as ours, and they won't be, then this can be a little complex to work out. So we've made a handy little online calculator where all you have to do is enter in the heights of each of the different layers, and it plots your soil texture on this chart. Look for the link in your email. So what if your soil isn't a beautiful loam like our imaginary soil? How can you improve your soil texture? Well, if you've got a really heavy clay soil, one that's dominated by clay, then you could, of course, add sand. But it can be a little bit impractical in anything other than the smallest of gardens, because you can literally be in a situation where you have to bring in tons of sand. You could add biochar, but the same deal. You need large volumes to really affect your structure. In some situations, you can add a product called gypsum, or it's called, or sometimes referred to as clay breaker. That's calcium sulfate, and it binds those little clay particles together to form larger particles. But it's only really useful in a particular type of clay soil called a dispersive clay. There's a simple test you can do for that as well, so we'll provide links in the resources as well. If you've got sandy soils, on the other hand, then you could add clay, but you run into the same problem. You're going to need large volumes of it, and it can be difficult to incorporate into your soil. And again, you could add biochar, it'll help as well, but same deal. It's going to be expensive at large volumes unless you're making it yourself. So what can you do? Well, it doesn't really matter what soil you've got. All soils will be improved by building up your organic matter. You can do that by growing plants like green manure plants. You can do that by adding mulch and keeping your soil covered. Or finally, you can do it by adding compost. All of those materials will break down and will provide large particles to act as air spaces between your clay, and will also act as binders for your sandy soil. Compost is a magical ingredient for garden soils, and we love making large volumes of compost. You don't have to make it yourself. You can purchase it in if you can find a good supplier, but it's such a magical ingredient. It's large particles. They act like sand in clay soils to open them up and introduce air and water. But it's also a great source of humus, the beautiful brown jelly-like material that holds water, nutrients, and binds sand particles together. And that's why it's great for any soil. Making great compost is, however, a topic for another day. Make sure you're signed up to our newsletter so if you don't miss out on any of our future free mini workshops, because I reckon a compost one might be in order as well. Okay, the next lens we're going to look at your soil through is the chemistry lens. And I really get into soil chemistry. It's another sort of thing that seems complex at first, but it's not too bad. There are an amazing array of different elements in the soil. And the chemistry of your soil affects the structure and biology too. Many of you will be familiar with the big three plant nutrients: nitrogen, phosphorus, and potassium. the NPK if you like. But calcium, magnesium and sulfur and their compounds are also incredibly important nutrients, and they can dramatically affect the soil structure. And then there's all the other ones, the zinc, the boron, the manganese, the iron, my favourite one, molybdenum. These are the major ones, but there are many, many more, and then thousands of compounds of these elements that make up a dizzying array of nutrients. And just like us, the plants, animals and microbes that live in your soil need a wide range of these nutrients to thrive. Thankfully, you don't need to know exactly how many of each of these elements and their compounds are in your soil. But it's handy to know a little bit about what's going on. So, if you like, you can get a soil test done, a full element lab test, if you like, but it can be quite expensive, and I wouldn't recommend you doing that until you're growing a significant percentage of your food, or let's say more than a third of your food from your garden, and because at that point it does become serious about your health. Or if you're having, some problem with growing things that you really don't understand. What about the nasties? At this point, a lot of people ask, well, what about pollutants and nasty chemicals that might be in your soil? Well, in Australia, we're really lucky. There's free soil heavy metal testing. It's available from Macquarie University's VegiSafe program. We'll link to that in the notes. But other than that, it's only really if you know something about the history of your site that might indicate that there is a toxic chemical in there of some kind. Maybe it was right next to a highway and you're worried about organic compounds from petrol or from fuel or oil or something like that. If you have a particular worry, or maybe it was an old apple orchard and you're worried about pesticides, then you can get tests done for specific pollutants if you suspect something. But it's too expensive to do a broad spectrum test of every different possible pollutant, because unfortunately we put a lot of different stuff out there over the years. And the other way that you can improve your soil chemistry is really by adding things. Now, if you do a lab test and there are specific elements that are missing, then you can add those specific elements, like you might be short of molybdenum. So you could add molybdenum to make sure your plants are healthy. But only if, like I said, if you're seeing some sort of problem that you can't otherwise understand. The other way is just to add a diverse range of organic fertilizers or organic materials. And some of the best ones aren't actually sold as fertilizers. They're just organic matter, like mulches and worm juice, worm castings, seaweed and weed teas. These are all things that you can make yourself or harvest from around you. You can even use human urine. It's got a really wide range of different nutrients in it, and it's non-toxic and totally safe. Just don't put it on the leaves of your plants. And you can add rock dusts. Finely ground rock dust is another amazing source of nutrients. And of course, compost, our old friend. Now, there is one test that you can do at home that can help ensure nutrients are available to your plants and biology, and that makes sure that any heavy metals that are in your soil have less impact. And that is a pH test. So these are really cheap and easy to get. They come with several parts. Usually they have a little plastic board like that, and all you do is you add some soil onto there, and then they'll come with a little container of indicator liquid, and you dribble the indicator liquid onto the soil until it's fully saturated, and use something then to stir it all up, mix it all in and make a mud paste. Once you've made that mud paste, you just take the powder that they have, it's called barium sulfate, and you sprinkle that over the top of your little mud pie, and then in a few seconds it starts to change colour. And you can then, they come with a coloured card, and you could just compare it, like in the photo, to the colour and work out what pH your soil's at. You can also get electronic meters, but the cheap ones don't work very well, and the good ones are expensive. So I recommend these little simple tests. They're quite cheap. You can get them from hardware stores and garden centres and the like. Now, soil becomes really locked up in alkaline soils, and metals dissolve and become soluble poisons in very acidic soils. So this is the scale here. The pH stands for parts hydrogen, but you don't need to worry about it. The scale goes from 0 up to 14, and your soils won't be at either end of that scale. They'll be much closer to the centre. But basically, it goes more alkaline as you move up that scale to a higher number. And like I said, in really alkaline soils, then a lot of nutrients become locked up. And down lower, it's more acidic. And in that sense, everything dissolves in acid. So things that potentially are toxic become water soluble and then go into your plants. What we're after is a fairly neutral soil, somewhere between around about 5.5 and 7.5, ideally somewhere between 6 and 7. And that will have happy, healthy plants and happy, healthy soil biology. Now, the reality is often your soil won't be in that range. If it's too acidic, if it's too low, down below 5.5 or even below 5, then the easiest way to fix that is add calcium, and usually that's in the form of garden lime, and that's a fairly safe additive that you can add to your soil. It's often with garden lime, it'll explain on the back of the packet how much to add. The other thing that you can, of course, do is grow plants that work well in acid soils. So always adapting is one of the sort of ideas in permaculture. So, things like blueberries grow fantastically in acid soils. If your soil is too alkaline, on the other hand, then you can add elemental sulfur or a sulfur compound. Now, they're not organic, so be careful, and they can potentially, like if you have something like aluminium sulfate or ammonium sulfate, they will make your alkaline soil more acidic and shift it to neutral, but they can do a lot of damage to your soil health, so be very careful with adding those. An easier way is just, again, add organic matter. Organic matter typically breaks down to be acidic in the soil, especially if it's a manure or something that's rich in nitrogen. The other thing, of course, you can do is grow plants that work well in alkaline soils. And the classic is the brassica family, your broccoli and your Brussels sprouts and your kale and your cabbages. They all do really well in reasonably alkaline soil. So, test your pH, work out what it is, and then adjust it back into that neutral range, and your seedlings will spring out of the ground and be super happy and healthy, and your gardens will flourish, as long as you've got the structure right and you've got your soil biology happy and healthy. So that's the final lens that we're going to use to look at our soil biology. Why is biology important? Well, good soil biology builds soil structure. It actually creates this beautiful, friable, lovely soil. Living things are doing that work for you. It also balances out the soil chemistry, and builds that magical ingredient, humus, directly there in your soil. It also holds on to carbon in your soil, and it can be one of the major sinks of carbon, locking it up a bit so it's not up in our atmosphere doing damage. And those microbes and critters down there hold on to nutrients and make them available for plants. In a sense, everything gardens. All those organisms down there are trying to make the environment down there better for life. And they help each other. They're all creating a garden. The soil critters that are down there are on your team. So you want to look after them. The negatives about having too much biology in your soil? There are no negatives. It's all good. It's all positive. Now, all of you are going to be familiar with these lovely critters, the earthworms that get into your soil and improve things. But it's not just about these big things. There are so many tiny little creatures and organisms down there that we can't see. There are at least 10,000 species and more than 1 billion individual bacteria in a single gram of soil. That's less than a sugar cube in size. It's just mind-blowing how complicated it is down there. There's a dizzying array of different creatures, a wild, diverse ecology that rivals the most complex ecosystems on Earth, and it's right beneath your feet. There are nematodes and arthropods, bacteria and protozoa, and my favourite, the fungi. This is Dr. Elaine Ingham, Through her organisation, the Soil Food Web, she's probably done more than anyone else on the planet to promote understanding and the importance of life in the soil. And this beautiful image is by a crew called the Lexicon of Food on Instagram. Go check them out. Now, through the miracles of modern technology, we can actually see what's going on down there. This is a little protist. And look at him. He's burrowing through the soil, making channels and improving the soil texture. This is by Edith Hammer. Check her out on YouTube. She's got a couple of other great videos like this of soil life. And then it's not just bacteria and microbes that are doing things like that too, but also fungi. This video by the Helmholtz Center for Environmental Research in Germany. Look at this. These big threads are a hyphae of fungus in the soil, and those are little bacteria using the fungal hyphae as a highway to travel through the soil and being carried by the fungi all around the place. Isn't that incredible? That's happening right now in your garden, and you can't see it, but you've got to respect it and look after it. So, how do you improve your soil biology? You can add biology or inoculate your soils with things like actively aerated compost teas, but making them is not a simple process, and that process starts with making really great compost. So is it really worth trying to add that specific biology like bacteria, protozoa, worms and fungi and the like? Yeah, but often it's easier just to inoculate your garden with compost directly. Compost adds the microorganisms and the nutrients and the food they need in one hit, because you better make sure that your soil conditions support your soil microorganisms before you add them, otherwise they'll just die anyway. So build the right environment for them by looking after your soil structure, by keeping your soil aerated and not compacted, by keeping your soil moist but not wet, by keeping living things feeding your soil, by having plants growing there, avoiding any nasty chemicals, and feeding your soil with a diverse range of different types of organic matter, again, including compost. Now, how much compost should you add? Well, we recommend not too much, about 25 millimetres or 1 inch each time you plant a crop. Just spread it on the surface and maybe just combine it with the very top of the surface, almost like a mulch. More than that, and you risk all those nutrients washing away in the next big rain. And the last thing we need is more nutrients in our waterways. So that brings us to Milkwood's 7 tips for healthy and resilient garden soil. Okay, the first one is fix your soil structure. Work out what it's like and either pretty much add organic matter to improve that structure. Secondly, check and adjust your soil chemistry. So do that pH test, and then once you've done that, maybe adjust your pH a little bit to make sure it's in that middle range. Keep your soil moist. Don't let it dry out completely. Try not to flood it. Keep it covered with mulches, or even better, with living things. Minimise compaction and disturbance, so don't destroy your soil structure. And then maximise diversity and keep it alive with plants. Finally, add a diverse range of organic matter. And then remember that even if you're not growing anything right now, we can all support healthy soil through eating a diverse range of different plants and supporting your local organic growers.